Hello everyone, Thirsty Nerd here. Today I'm going to be showing you guys a solution I've come up with to make decent reactive fog in Unreal. A big problem I've found with a lot of tutorials is that either they're overly complex or they're not performant. So I've developed a relatively simple system here that will allow your main character to walk through fog particles in a way that will um, disperse them as you walk through them, and then slowly come back to their original position, all in a very performant manner. This method will not work for um, more than one actor. And if you need this for like your main character in your single player thing, that will be the best use case. You'd probably have to do a decent amount of modification to get this method to work with more than one actor. So yeah, in essence, what's happening here is pretty simple. Is we have a fog volume BP that has a mesh, a collider, and the system itself attached to it. And what happens is on begin play, it sets the reference for the player, and then if a player overlaps, it starts ticking the blueprint. And on tick, all it does is send the location of the player to the Niagara system, and then the Niagara system handles everything else. And because Niagara is pretty efficient with regards to like rendering lots and lots of particles and updating um, a singular variable, this is super efficient, and it's there's thousands of these particles in the scene, and there's maybe like a microsecond on the GPU cost. So let's show you how I went about doing this. First, you'll want to create a blueprint class. An actor is fine. And blueprint fog tutorial. Here we will have a static mesh to be our, and this can be any static mesh. I just use a plane because that's the easiest to demonstrate with. Later on, I went and just made some new planes out of the spline function in the modeling tab. But that's in theory, this should work with any mesh. And if you wanted to like have like depth to the fog of it, like having like this is just a single layer. If you wanted to have like layers of it, you just need like multiple planes stacked on top of each other or something along those lines. But we have a plane, like a box collision, and we'll have it match. We'll put it underneath the plane attached to it so that it retains some of its scale and such. We'll just make it very roughly what it looks like there. And then on begin play, what we're going to do is we are going to get all actors of class. And my character for the there's only going to be one of my third person character in the scene, which is my main character, which is the player character. If you were to have like multiple characters you wanted to react to the fog, you'd have to find a different method, because this is basically just going to set a Niagara user parameter each frame. Let's now make a variable down here that will be a third person character. Third person, just here we go. And call that our character reference, player reference. Oh shit! This is my old one. Third person character. It's my legacy one from before. Here we go. This is the right one. set this. Then whenever this collider here on overlap, one component begin overlap, and we'll have one component end overlap, and the other actor we'll just do is a reference. Where is it? Soft reference is what I'm looking for. Is a soft reference for our third person character. And this is basically going to check if the overlap actor is a third person character, then do this. And what we're going to do is just enable tick. Set actor tick enabled. We're going to do the opposite for when we end our overlap. There we go. Let's just comment our stuff. Start and stop tick. We want this to not start with our tick enabled. And this is a set player reference. Now we're going to take a brief detour in order to do our VFX. We'll start off with, I guess, hanging particulates. It might be the closest what we need. I won't be showing how to make the material for a fog, but there's plenty of resources out there for that. Tutorial fog. What we're going to be doing is showing an easy way to set this kind of thing up. This might be fine. So our initial location is going to be based on a static mesh parameter, which is basically just going to inherit the static mesh from the parent. I'm not sure we need this parameter actually. I think this attached parent might work properly. We'll just use a plain. You need to make sure it has CPU access. So you can see that like all the particles are now spawning on our static mesh. And what we want is we want a vector parameter for our player's position. And we'll use this to basically set a force parameter that will push stuff away from that position. Start with a point force. And in this point force, we will basically want the point force to originate from the we'll just start with the player position for now, just so that we can like show off what we're doing, and we can also draw a line to origin so that we can debug and show what's going on. And basically in here now with on tick, we can get our player reference. First we'll add that tutorial system to the plane tutorial fog. So there, it's attached to the plane now. We will bring it out, set vector parameter, set Niagara variable vector 3, I believe is what we're looking for, and we called it player position, correct? Yes. So we, in our variable name, we have to type user dot player position. And then we need to get our transform, get maybe actor location is what we want. Yeah, that's what we want. And then this in theory should be something akin to what we want at the base. Tutorial fog is what I call it. Bring it over. And this is just debugging to 0, 0, 0 for a force because it's that's currently where this player position is set to 0, 0, 0 on by default. What we want is we do want to fall off. And that I think should make it so that even though this force is all the way over here, because there's a fall off, it's not going to do something stupid. Let's throw this up a bit, and we're going to increase the radius of these as well so that we can see them better. Now we should be able to see these guys. I'll just put my player start closer to there for a brief moment so that we don't have to constantly run back to demonstrate. Alright, let's see. So, oh, I need to turn off collision for my plane, but you can currently see that's where it's displacing the particles very, very softly, I believe, because the force is really soft and there's a fall off that's not very big. So increase the fall off, increase the force to like, I don't know, 700, let's say. Let's see if that makes a difference. Yeah, and then you can see they like move away now. Now there's two problems here. One is because they have the actor Z here is above where their initial positions are. They are just kind of flying off up and down in a way that is like unseemly and you wouldn't like it. So what we're gonna do is basically we're gonna double down on a solution here because there's a second issue too of these guys aren't returning to their initial location. So what we'll do is we will create a user parameter that is basically we'll just call it Z. It's a float. And it's going to be the Z value that we pipe into the force here. And the Z value is going to be based on its initial position. So we're going to set a newer existing parameter. Okay, so we're going to set a parameter. We're going to make a new vector. We're going to call it starting position. And the starting position is going to be based on the position here at spawn. This error is not super relevant unless you have a very large open world. So yeah, when the particles initially spawned, the position it starts at is going to be the position here that we're like noting down, and using that we can first of all make a point force that then is basically the opposite. That is like, I'm going to slowly return, and this one won't have a fall off because we want it to slowly return, regardless of how far away from its initial position it gets. And this will be based on starting position. Here we go. And using our starting position as well, we can actually, I believe it is make vector. What we want to do is we want the X and Y from our player position here, but we don't necessarily want the Z. In fact, we'll just use the Z from our starting position. If I can remember how to do this. Oh, of course. It's because this is a float. So So we make float from vector, and the vector will be starting position. And then we want it on the Z channel. And I think in theory this should be close to it. Here they'll push away, and then they'll slowly come back to their position. And this is the gist of what's going on in my fogs over here. I just have a slightly nicer material applied and a little bit more tuning going on. It turns out we didn't need the this is Z parameter at all. So yeah, that's about it for this. Anyway, I'll see you guys around. If you guys like the content, I stream game dev on Twitch a couple times a week as well. There's a link to my Discord down below. Feel free to like, favorite, subscribe, all that jazz. It really helps out. And I'll see you guys around.